Once, we thought comets were just dirty ice balls flying around the sun on their ancient orbits. But in 2025, something flew into our solar system that made astronomers both excited and a little nervous. This is the Interstellar Comet 3I Atlas, only the third known object that has come to us from another star system and is now just passing by without staying. At first, it looked pretty modest. Faint, dim, far beyond the orbit of Mars. It was discovered by the Atlas telescope on July 1, 2025, and at first nobody expected anything sensational. But orbital calculations quickly showed this is not an ordinary visitor. The trajectory of 3I Atlas is hyperbolic, which means it's not gravitationally bound to the Sun and is simply piercing through our system, only to head back into the depths of the galaxy. Some scientists even suggest it may be older than the solar system itself and might have come from the thick disk of the Milky Way, where very old stars move. As the comet approached the Sun, the most powerful instruments joined the hunt. Ground-based telescopes, space observatories, and even spacecraft around Mars. When 3I Atlas passed not too far from the red planet, orbital cameras tried to resolve its structure from tens of millions of kilometers away. Astronomers wanted to understand what exactly this icy wanderer is made of after surviving billions of years in interstellar space. And that's when the first surprises began. Observations showed that the composition of 3I Atlas is noticeably different from most ordinary comets we're used to. It turned out to be unusually rich in carbon dioxide, while comparatively poor in water. In its gases, scientists found traces of carbon monoxide, cyanide, and even unusual sulfur compounds. Polarization measurements revealed strange properties of its dust, as if it were a mixture of very dark, ancient material and ice, somewhat reminiscent of bodies at the outskirts of our own system, but still different. All of this is a set of clues about the conditions in which its native planetary system formed. In the fall of 2025, 3I Atlas became a real news star. At the end of October, it approached the Sun at a minimum distance of about 1.36 astronomical units between the orbits of Earth and Mars. At that moment, several spectacular things happened at once. First, the comet's brightness rose sharply. It flared up and became noticeably brighter than expected. Second, observers noticed a temporary change in the color and structure of its tail. From the outside, it looked as if the object literally came to life when it got closer to the Sun. The activity of its nucleus suddenly intensified, releasing new portions of gas and dust. And then something happened that triggered headlines about a radio signal from an interstellar comet. After 3I Atlas passed behind the Sun and reappeared, radio telescopes picked up an unusual radio emission coming from the region where the comet was located. The media instantly spread phrases like, "Astronomers detect a radio signal from an interstellar comet for the first time." Sounds like the start of a sci-fi movie, doesn't it? In reality, the nature of the signal turned out to be far less dramatic and far more interesting scientifically. Radio astronomers carefully examined the data, the frequencies, the shape of the signal, its stability. They found no signs of an artificial origin. It wasn't a transmission, not a code, not a pattern resembling communication. Instead, the signal turned out to be a combination of natural processes. The interaction of the comet's ionized gas with the solar wind and background cosmic sources. Essentially, for the first time we heard so clearly how an interstellar comet hisses when it's blasted by the stream of charged particles from the Sun. Still, the story didn't end there. Back on the scene came a person many already know from controversies around another interstellar visitor, Oumuamua, Harvard astrophysicist Avi Loeb. Even before 3I Atlas passed its perihelion, he suggested that the object might not be just a comet, but a technological device or even a mothership releasing small probe drones. Fresh data only poured fuel on the fire. Some images of 3I Atlas showed strange structure, as if the bright glow was not behind it along the direction of motion, like a normal tail but slightly ahead in front of the object. On other images, X-shaped jets or crossing streaks around the comet appeared. Loeb proposed a bold hypothesis. What if this is not just gas and dust, but some kind of beam or particle stream that clears the path ahead of the object from micrometeorites? like a ship scanning the space in front of it and deflecting dangerous particles with a magnetic field. In a separate work, he even put forward the idea that 3I Atlas could be heading toward a special region near Jupiter, where the giant's gravity dominates over the sun's gravity. Such a region is indeed convenient if you want to drop spacecraft or satellites there while using minimal fuel. And in fact, calculations show that on March 16, 2026, 3I Atlas will pass about 53 million kilometers from Jupiter. That is close in cosmic terms, and at that moment the Juno spacecraft, which has been studying the gas giant for many years, will be observing the comet. It sounds like the perfect plot. An interstellar ship approaches Jupiter, drops mini-probes there, and we record everything. End of the debate about extraterrestrials. Amid this hype, Loeb even entered a public bet. He accepted a $1,000 wager from well-known skeptic Michael Shermer that by 2030 humanity will have found confirmed evidence of extraterrestrial intelligence. If that actually happens, the money will go toward a scientific project searching for such traces. But it's important to understand, within the scientific community, such ideas are still at the very edge of possible explanations. Most astronomers look at 3I Atlas much more calmly. For them, this comet is first of all a unique laboratory for studying what icy bodies from other planetary systems look like. Its strangeness, unusual light polarization, richness in carbon dioxide, brightness outbursts, and complex tail shape can still be tentatively explained by a combination of natural factors. Its specific composition, the age of its material, viewing geometry, the solar wind, and microexplosions on the surface of the nucleus. Another key point of interest is how its tail and coma changed after it passed perihelion. At one point, observers thought the comet had lost its tail altogether, as if the bright stream had just vanished. Later, with more detailed images, it turned out to be a geometric illusion. The tail had turned almost directly away from us, so it appeared much shorter and weaker. After that, astrophotographers caught it again, and it became clear that the structure was actually very complex, with several components and different flows of dust and gas. All these new facts fit into one picture. 3I Atlas is an object that is both very unusual and, oddly enough, reassuring. Not because it poses no threat. Its trajectory doesn't come anywhere near Earth, with a minimum distance of about 270 million kilometers, but because we are observing in detail how an interstellar comet behaves as it flies through our system. We hear its radio whisper, see it flare up when it meets the sun, and study its ancient dust and gases. So what's next? Right now, 3I Atlas has already passed its closest point to the sun and is gradually moving away, but at the end of 2025 it is still relatively close to Earth. Large telescopes and skilled amateurs continue to image it. Ahead lies its approach to Jupiter in March 2026. That will be another key moment. The spacecraft near Jupiter and ground-based observatories will simultaneously watch whether the comet's activity changes, whether new strange jets, outbursts, or other anomalies appear. If it turns out that everything is explained by normal cometary physics, we still win. We'll be left with gigabytes of data about an interstellar object that flew through our system and allowed us to peek into someone else's planetary kitchen. If there is even a hint of something truly artificial, then 3I Atlas will go down in history as the most important stone messenger humanity has ever seen. For now, the interstellar visitor continues along its hyperbolic arc, and we're like people standing on the side of a galactic highway, watching a foreign icy wanderer race past. We still don't know how many such objects cross the solar system every century. But one thing is already clear. 3I Atlas has reminded us that our system is not isolated. Fragments of other worlds are constantly flying between the stars, and sometimes we get the chance to look at them up close. And maybe someday, when someone goes back through archival images and radio recordings, they'll notice something in the data on 3I Atlas that we've missed so far. For now, it remains a unique, but still natural interstellar comet that, for a few months, became the main character of news stories, debates, and theories about whether we are alone in the universe.